Hey guys, welcome to this first video, and today we are with a 1976 from the dates on the Transformer Fender Twin Reverb. And I bought this thing in Venice last week for dirty cheap, and there are a lot of things that are not really working with this amp. And one of the first few things that I noticed was the speaker configuration. It had one thing like this and an Eminence speaker, and this Celestion one is 25 watts. And you know that this thing, it's a 100-watt amp, so that didn't quite add up. And the other one was even worse because the impedance didn't match up, and actually the impedance that this amp was seeing was like 12 ohms when it should be 4. So hopefully that didn't mess up the output transformer, but let's bench it up and I'll show you what's wrong with the inside. So as you can see, the amp has been recently serviced. We have new caps, and I'm gonna show you also in the doghouse we have new caps. The problem with this repair is that the electrolytics on the pre and here, they haven't been changed. One nice thing is that the power cord has been changed. We're gonna check those solder joints to make sure that they're not cold, they're not like giving up on us. The interesting thing about this amp is that when I got it, I plugged my guitar in the normal channel and nothing was coming out. Then I looked at the back and I noticed that V1, so the first valve on the input stage of that channel, was missing. And I said, okay, why? I went back, I looked for 15 minutes in my car, thinking maybe I dropped it, moving it, but was nowhere to be found. So I guess it was missing the preamp tube. So that is something. But right now, what I'm gonna do is I'm gonna check those caps. I'm gonna tilt it over because I want all my repairs to have the value of the cup showing up on the outside as soon as you look at them. And then we're going to change those caps to the pot mod on this thing. We're gonna add the trimmer to the bias. We're gonna re-bias the output valves. We're gonna put new preamp tubes in it, and that's pretty much it. I've got my tip at 700 degrees. I use a wet paper towel to clean my soldering iron tip. You don't want anything that scratches, because otherwise you're gonna rub off the coating that it's on the tip and you're gonna have to change it. I'm gonna change also those resistors that are underneath here, just to make sure that everything looks good, and those resistors needed to be changed anyway. Make sure that this thing has been powered off for a while before you start touching here. So this thing has been plugged off for like a week, so I'm pretty sure there's nothing in here. make sure to have the cap steady when it's cooling off, when the solder joint is cooling off. Otherwise you end up having this kind of thing that it's a cold spot, and that's obviously not good. Now those ones are the main caps, and you want to be extremely careful when mounting them because see they are in series, right? So this is where the hot from the transformer comes in, actually the hot from the rectifier comes in, and this is ground. So if you want to make sure that this is the ground, you can take a multimeter, put it on beeper, test here, test anywhere in the amp. That's your ground. Huge cold spot here. Now we're gonna swap those two resistors. Let's clean up those solder joints real quick. Alright, now it's much better. We can close this thing up and move to the next steps. Here you're gonna need like a long screwdriver because the output transformer is in the way. Always cross whenever tightening up bolts and nuts and whatever. Beautiful. Alright, now we move inside and we're gonna switch those 6 actually, 1, 2, 3, 4, 5 and 6 electrolytics that are long overdue. Gonna put some solder just to get it going. So these ones are called cathode bypass. They work in conjunction to the resistor. If you can see, they are connected in parallel, and one goes to the first valve and the other one goes to the other one. And the reason why we need a cathode bypass cap is because we put this resistor here to help with the biasing of the tube, in this case the two preamp tubes. And one interesting property of this resistor that we're putting there is that it allows to create a positive feedback between the temperature, so the current that flows through that resistor and eventually inside the tube, and the actual resistor value. So basically it helps stabilizing in temperature the tube or the transistor. It applies the same way with BJTs and whatnot. So the drawback of using that resistor, with the technical term is called ballasting resistor, is that it reduces the gain, but the polarization happens in DC while the gain happens in alternating current, in signal current. The way we neutralize the gain reduction effect of that resistor is by bypassing that resistor with a huge electrolytic cap in parallel to it. So that's the story. So remember, here is the ground, and you can see there's a wire that goes straight to the ground strip. If you're unsure of which one is ground, you just grab your multimeter, tester, whatever, and you touch between that point and anywhere on the chassis, and if it bips, that's ground. Do not cut stuff in here because it's gonna stay here and it's gonna cause shorts. So if you need to cut outside. Alright, now the same thing for the other ones. Now this is where I want to do the mod. If you look at the schematic, which I strongly advise you to print every time you're working on an amp, is here. We have this 470 kilo ohm resistor, and this is where the actual reverb goes in. And if you can see, this resistor is actually, yeah, it's cracked. Okay, so this thing is blown, buddy. So the way I like to do it, and the reason why this thing is blown, is because the current that flows through here is way high. So how I like to do it is basically increase the resistance a little bit to 1 kilo ohm and put a bypass cap on there to make sure that we are not affecting the gain too much. So as you can see, it popped right up. There's no way in hell that that thing was working. So it turns out this thing is pretty short. So what we're gonna do is this thing. Alright. We're gonna create like a combo thing. And the way we're gonna do it is we don't want the resistor laying on the cap. So we're gonna do something like this. slightly, so maybe on top. All right. Let's put it here so it's not that crowded. All right. I want to be careful with these filament wires. We don't want to hit any of those. So this one. Now I checked the output stage resistors. They have been changed recently, so I'm not gonna swap them out. And the last thing we want to do is fix the balance. Here we're gonna add a pot in series to the resistor, and then we're ready to fire it up, regulate the bias, and see how this thing sounds. Now we're gonna use a 10K the original one was a 15K Now we're using a 10K resistor in series to a 10K pot, so it should give us enough wiggle room for both making it hotter and cooler. So it should be like a nice spot to be. All right, now we have our trimmer in place. Everything looks cool, everything looks nice. Now what I'm gonna do is I'm gonna bring the head on the amp, connect the speakers, and connect my bias instrument, and let's bias this thing. Alright, now we're ready to fire it up, and what I did is I connected this instrument, which is gonna record the milliamps of grid bias current that is gonna flow in the two channels. And as you can see, I covered up everything, so we make sure that if anything blows up, it doesn't go through your eye or it doesn't go anywhere we don't want to go. I had a bad experience when I was a kid with that, and we just had a little entrance there to make sure that we can access the balance pot. So we're gonna see that the balance pot is gonna control the differential current that flows between the two channels of the push-pull, of the output push-pull. So we're gonna see that when we start fiddling with the balance, one's gonna go up, the other's gonna go down. But when we start fiddling with the pot that we just added, we're gonna see that they're all gonna go up or they're all gonna go down. So let's fire this thing up. Alright, the amp is extremely quiet. So right now what we want to do is, you can see there is an imbalance between the two channels. We want to bring that imbalance back down, and then we want to make sure that the grid current going through the two things, it's all right. Okay, so let's start with the imbalance. All right, looks pretty good to me. Also, now the thing is perfectly balanced. The reason why I love this instrument rather than any other one is because this thing allows you to see both channels simultaneously. You don't have to switch back and forth, and it's analog, it's not digital, so you can be really fine-grained with this thing. Now, the current. We want to be at like 65-70% dissipation. I feel like we are already there, but let's go check the numbers. And it's pretty easy to check the numbers. There are 1,000 different ways to do that, and how I like to do that is, there's this online tool. You just select the tube and it pretty much goes by itself. So you can, on this Reverb website, you can select the output tube, which is a 6L6 GC in this case, 6L6 GC 30 watts, plate to cathode voltage. This it is 445. If we run it at as a class AB fixed bias, we should be at 40 milliamps, and we are exactly there, so we don't have to touch. This completes our repair. Let's let it cool it off, and let's bring it back together, and let's fire this thing up. Let's see how it sounds. Alright, time to fire this thing up, and the first thing I can say you is this thing is extremely silent, and this means basically two things: the power circuit, the AC caps that we substituted, the previous technician substituted, and the resistors that we substituted are doing their job. But most importantly, since the push-pull, the real deal of the push-pull is to drive with a 100-degree shift between the upper side and the lower side, means that the common mode rejection ratio should be ideally infinite. And the balance that we did, the balance adjustment that we did, was specifically to balance out the upper and lower channel to make sure that the noise is exactly a 180-degree shift, and that the amplitude on both channels is the same, so it cancels out pretty nicely. And yeah, the bias turned out really nice. Now I'm gonna fire this thing extremely low because I'm in an apartment and I don't want to get kicked out, but I mean the reverb is amazing on this thing. And I'm playing through a 1950 custom shop Fender Strat. I mean, this thing is a beauty, and I'm just disappointed that I can't try the vibrato, because the guy that sold me the amp didn't have the pedal to kick it on, and mine is somewhere in the Amazon network waiting to be delivered. So that's a shame. I'm probably gonna do another video about it, but so far so freaking good. I'll see you in the next episode.